talking about the theoretical analysis. So we will think of this high-level description as mentioned. So it characterizes running time as a function of the input size n. Okay, we usually make use of term n, okay, to symbolize the number of input or the problem size. So we also take into account all possible inputs, and it allows us to evaluate the speed of algorithm independent of the hardware and software environment. Okay, as mentioned, if you are using supercomputer, okay, the speed will be much faster than that of your mobile devices. Okay, so the software environment, okay, it may also affected by the OS you're using. So we want to eliminate all these factors that are affecting your algorithm. So we will try to estimate the runtime. As mentioned, the meaning of big O. Okay, what do we mean by big O notation? Okay, is in the runtime. It's just like the notation showing the growth rate. Okay, we have just mentioned. Include, okay, big O1 as a constant time. Big O(n) is a linear time corresponding to the input size, and n squared will be a quadratic time, and big O log n is a logarithmic time. Okay, this is how we can refer to the different growth rate of the arithmetic efficiency. So the trick is to investigate the lasting of loops due to input and look into the steps into a loop due to input. Okay, that is, we would like to look into what are the steps involved due to different size of the input. Okay, so again, we are focusing on the worst case situation. Okay, let's see this case. Okay, for this simple arithmetic A, you can see that the value of I is counting from 1 to n. Okay, and it would, for each value of I, it would go through this step, right? So if the n, this n is growing large and larger, okay, the number of steps will inside the for loop will go linearly, right? When you increase n by 1, the number of steps of this for loop increase by 1, right? That is the first consideration. So how about another one? Okay, we can use another method to count, okay, this total. Okay, counting 1 plus 2 plus 3, so on and so forth until n. Another method. You can use, okay, this nested for loop to get this value, because you get total equals to total plus 1. Okay, it is another workable method. Okay, it can also give you the desired result. However, you can see that the size of running in terms of arithmetic efficiency is much lower, because you can see that it would go through this total equal to total plus 1 in a nested for loop. So you can see that the big O notation will be n squared, because when the n is increased linearly, but the number of steps will grow quadratically. Okay, 即係 square 咁樣上下。So that is another thing, okay, you have to think about. Okay, this algorithm C, okay, as long as we have n, then we can just have n times n plus 1. Then in this case, we actually have a constant time, because no matter number of n, we have the same number of steps involved, right? Okay, so in this case, okay, we can see that arithmetically, algorithm C is the best option among these three, right? Okay. So this is the first consideration. So how about the this case? Okay, we have learned how to get the size, right? How to get the size of in a linear list. Okay, because when we get the size, we just return the value. Okay, in this case, no matter how long is the train, as long as this function is already implemented, the size is available, then we can get the size of BigOh1. Now we pronounce it as BigOh1 đại cái O và BigOh. Nhất là referring to the constant. Okay, how about another case? Okay, we get something from the linked list. Okay, I hope you still remember that. Okay, when we are working on it. Okay, so what is the best case? The best case is that the first node is the one you want to get, right? You get index 0. Then you don't need to go further along the train. Then you just get the first one, point by the first node. Then you can get the result. Okay, it is the best case. How about the worst one? Okay, it means that if we have to go through all the nodes along, 即係你最唔好彩嚇 okay, the worst case situation. You have to go through all the nodes one by one till the end. Therefore, it would go for n nodes. So, in the worst case situation, the BigOh notation will be BigOhn.